The reason why we defined the cross product is because of its nice general properties, which we will list below. First of all, we calculate the cross product between A and B, then it's minus B, the cross product of B and A. So it's not a commutative operation. Another way of expressing this is saying that the cross product is oriented. We'll return that later. The cross product of A with itself for an arbitrary vector A equals the zero vector, which can be shown rather easy. Well, if we multiply one vector with a constant c, then we end up with c times the cross product. The cross product relative to taking sums of vectors shares the distributivity property. So building the cross product of A times B plus C equals the cross product, the sum of the cross products A and B and A and C. Finally, if we take a dot product of a vector A with a cross product B and C, then it's similar to interchanging the role of A and B, B and C. So we stick to the cross product of A and B dot product with C. Well, the important thing about the cross product is that if we start off with two vectors A and B, then actually we see that the cross product is perpendicular or orthogonal to the vectors we started off with, A and B. Well, how do we see this? Well, we show that actually the dot product of A with A times B, on the basis of property 5, we can switch the order. So we get the cross product of A with A and B, and A makes 0. The 0 vector times B is 0. So on the other end we can do the same. The cross product of A and B equals minus B times A. That's property 1. So now we use the fact that we can get out the constant c, or the minus sign here. You remove it to the left. Then we get the inner product of B times the cross product B with A. Now we use property 5 again to see that it equals B times B dot product A. And B times B is again 0. The 0 vector times A makes 0. So actually the inner product of A with A times B equals 0. So these vectors are perpendicular. So actually what is said here in this corollary is that if we start with two vectors A and B, and we want to construct in R3 a vector that is perpendicular or orthogonal to both of them, then we might just pick the cross product of these vectors. So it's a very easy calculation tool to find orthogonal parts in R3.